Hello everyone, this is Dr. Dhiman, and in this video we will learn about the law of resistance. That means we will see the laws that are followed by the resistance of a material. First of all, we have to understand what is a resistance. The resistance is the property of a substance due to which it opposes the flow of electrons, or we can say that it opposes the flow of electricity flowing through it. Okay, in simple terms we can say that it is the property that opposes the flow of electrons. So first of all, let us take some examples, then we will see the law that are followed by the resistance of a material. Suppose this is a conductor, suppose this is a circular conductor, and it has, suppose, some cross-sectional area is equal to capital A. Suppose this length of this conductor is L, okay, small l. Then we have to see what will be the resistance of this conductor. So first of all, we have to understand that if this L or the length of this conductor increases, this in turn will increase the resistance. Okay, this is the property. So we can write it as R is proportional to L. That means this resistance of this conductor is dependent on the length of this conductor, and it is directly proportional to the length of the conductor. Secondly, we have another term, another dimension, that is the A, that is the cross section of this conductor, and this cross section is inversely proportional to the resistance. Okay, so we can write it as R is inversely proportional to A. That means R is proportional to 1 by A, that is R is proportional to the inverse of the cross section. Now let us combine this. So what we can write? So R is directly proportional to this L divided by A. This is the resistance. If we want to remove this proportionality symbol, and we have to replace this proportionality with some constant, and let us assume that the constant is rho. Therefore we can write R equal to rho L divided by A. So this is the resistance of this conductor. Now let us assume we have one cube block. This conductor can be anything. Suppose this is a cube block. So what we have, this, suppose this dimension is, here we have 1 meter, this side is 1 meter long, this side is again suppose 1 meter long, and suppose this thickness, so this line is suppose 1 meter. Suppose this is a cube that has 1 meter of length, 1 meter of width, and 1 meter of thickness. Now if current flows through this, so what will happen? Suppose this current flows from this direction left to right. So what will happen? So R equal to rho L divided by A. This L is 1 meter. So we'll replace now. Therefore R is equal to rho. L is 1 meter. And A is the area of cross section. So this area, what will be the area? This is length into breadth, therefore 1 into 1 meter square. So this area here, this area will be equal to A equal to 1 meter square. So this will be 1 meter square. Okay, so this R is equal to rho. Okay, for this unit dimensional cube, we have this resistance is equal to this constant. This constant is named as the specific resistance or resistivity. So this is the formula for resistance. Now we will see what are the law followed by this resistance of this conductor. The first law states that this resistance varies directly with the length. The resistance varies directly with length. So this length is here small l. So what we can understand, that means if we increase the length of this conductor, the resistance is increased. Okay, so in the first step we can see here, this is the case here. R is directly proportional to the length. So when we increase the length of the conductor, the resistance of the conductor will increase. If we decrease the length of the conductor, the resistance of the conductor will. Now let us go to our second property or second law. In the second law, we can say that the resistance of the conductor varies inversely as the cross-sectional area of the conductor. The resistance of the conductor varies inversely as the cross-sectional area. This is the second case. Okay, so R is proportional to inverse of the cross-section. This means if the area of cross-section increases, the resistance will decrease. That means here we can see if this A value, that is if that means diameter of this suppose circular wire increases, the resistance of this wire will decrease. Or we can say if this resistance, or we can say if the area, cross-sectional area, that is the pi r square for a circular conductor, so pi r square will be the cross-sectional area when value of r, that is the radius of this conductor, increases, the resistance of this conductor will decrease. Or if this area of this cross section of this conductor decreases, the resistance will increase. Okay, so this is the second property. Now let us go to our third property. In the third property, we can say that the resistance of a conductor depends on the nature of the material. So nature means here the type of the material. Different materials have different number of free electrons. So depending on that, the resistance of the device or the resistance of the conductor will be different. Or we can say that the resistance, that is it, depends on nature of the material. Okay, it depends on the nature of the material. That means some material have lower resistivity and some has higher resistivity. Now let us come to our fourth law of resistance. The fourth law is that this resistance of a conductor depends on the temperature of the conductor. It depends on temperature of the conductor. That means the similar conductor may have different resistance at different temperature. So we have already seen that this is the formula for resistance. Now let us see the unit of resistivity. So we have already found that the resistance of a conductor R is equal to rho L divided by A. Now we have to find out the unit of this resistivity, rho. Rho is equal to RA divided by L. This R resistance is ohm. And for this A, that is the area of cross section, the unit is meter square. And this L is the length of the conductor. So what will happen? This L, the unit will be meter. So unit of resistivity will be ohm meter. Okay, ohm meter. Okay, so this is the unit of this resistivity. If the temperature is equal to 20 degrees Celsius, rho of aluminum, that is the material is now aluminum, so the resistivity of aluminum will be 2.8 ohm meter. Okay, again we have the resistivity of suppose brass. This is another material. Okay, so what is the resistivity? It is in between 6 to 8. Okay, it varies between 6 and 8. This is 6 to 8 ohm meter. If we want to see the resistivity of most widely used material, that is the copper, it is 1.72 ohm meter. This is annealed copper. Okay, so in this video we have seen that this resistance follows 4 rules. These are the 4 rules. If you are not yet subscribed to my channel, please subscribe and hit the bell icon for future video upload notifications. Thank you.